Okay, good morning everybody. Thank you, Håkan. I'm going to spend the next 20-25 minutes talking about the purpose, process and input bases for the ground model. I thought I'd just start off by asking, or in fact discussing, what our task group had as its remit. What is a ground model? As mentioned, we had some 18 countries involved in this process in our task group. Were we going to come up with a universal ground model that we could all agree upon, or would we in fact disagree? The answer's yes and yes. We agreed, we disagreed along the way. I think until we realised that there is no such thing as a universal ground model. There's not one size fits all. A ground model can be many things. So I think that was our first light bulb moment, if you like, that we realised that a ground model is not a fixed item. So we've got two definitions for a ground model. One in part one, which you probably saw this morning in the introduction in the amphitheatre. So it's a site-specific outline of the disposition and character of ground and groundwater based on results from ground investigations and other data. Then in part two we have a similar definition that actually brings in specifically geological, hydrogeological and geotechnical conditions based on the ground investigation results. I think perhaps I would like to have seen the mention of other available data here as well, but anyway, we have a definition in part one, so I think it's fairly well defined. I think it's important to recognise from the outset that these definitions offer a clear distinction between what we've produced, a ground model, and what other people will know as a geological model. Now, some 27 years ago, Fuchs produced a definition of a geological model when he said it's a representation of the geology at a particular location. Now, in our paper, we give this model as an example of a simple geological model. And many of you will recognise this. This is perhaps one of the first things you think of when you think of a project. What will the geology be? But of course, what this does is provide nothing on the groundwater regime, nothing on the structures that we might have on our site, and obviously there's no geotechnical input. So one of the simple models that we've illustrated in our paper is this, a simple ground model based on some knowledge of the geology, but also on some structural loadings that we anticipate and some ground investigation data. And of course, key to this is that groundwater information is added. So as a task group, we were given the remit or the job of assembling the ground model, producing a paper on how to go about assembling the ground model. And in attempting to find a ground model that all our European colleagues could agree on, we decided not to follow the work that's been done by the International Association of Engineering Geologists, because they've gone ahead and produced a separate guideline entitled Guidelines for the Development and Application of Engineering Geological Models on Projects. And what they've come up is something called an Engineering Geological Model. And I hope this doesn't confuse everybody talking about our ground model and this EGM. But they've made a clear distinction because they've said an EGM is an interpretation and assessment of the engineering geological conditions, and this allows interaction of these conditions with the proposed project to be evaluated so that appropriate engineering decisions can be made. The EGM, as proposed by the IAEG, is not linked to a specific structure or structures. So as such, the ground model that we proposed is significantly different, as I'll explain. So what's the purpose of a ground model? Well, the ground model it can be a verbal, it can be a graphical, or it can be a schematic tool and a process that's used to advance our knowledge of the ground and groundwater conditions or characteristics within the zone of influence, and I'll explain that a bit later, for the structure or structures that we're considering, and its aim is to help identify corresponding risks. I think this is key the ground model, in whatever form we produce it in, must be understood by all geoprofessionals, the whole team that's working with a project. A ground model must consider the zone of influence because the two are linked, and again I'll explain that a bit later. And it's important the zone of influence is defined at the same time that the ground model is first thought about. The relationship between the ground model and the zone of influence is explained and developed as an important concept in our paper. So this table gives some of what I think are the key contributions a ground model can make to the process of constructing any structure or structures. On the left-hand side, I won't read this through, but there are various aspects that I think are important, and the contribution the ground model makes to our overall development of those structures are given in this table. And I'd single out three that I think are particularly important, and those are engineering quality and control during the life cycle of the project. They allow cost and timeline reduction, and also at the bottom, communication. I think communication of what we think the ground model is and should be with everybody that's involved is key, really. So to reinforce the purpose and usability, we've got some shall clauses in part 2 of the code. The first one says it requires us to document any variability or uncertainty that we have regarding geological, hydrogeological and geotechnical conditions, and it tells us that we should include this in the ground model. Second, the detail and extent of the ground model shall be consistent with the geotechnical category and the zone of influence. Third, and I think this is also key, the ground model shall be progressively updated based on new information as it becomes available. The ground model is not a static model, it's continually evolving as new data is accumulated. The ground model shall reference derived values of ground properties for the units that we've described within our model, and it should be documented in the ground investigation report. As an alternative to this, however, you may document it in the GDR. So that's the background, if you like, the skeleton on which we hang everything to do with the process of constructing the ground model. In terms of the process of constructing the ground model, I think it's important to say this is not a tick box exercise. It's not a question of just saying, yeah, I've thought about it, done, put it to one side. That's not what the ground model is about. The process of constructing the model should force us all to think about the ground and groundwater conditions and how they will interact with the structures that we're proposing for our site. However simple the ground model is, it must reflect all the potential ground and groundwater issues. And it's vital to link the ground model to the zone of influence of the structure or structures being considered. And in my experience, this is often not done, they're not linked, and this leads to errors or omissions of the data that we capture. Of all those bullet points, I think the second one on there is probably the most important. The process of constructing the GM must force us to think about ground and groundwater. So take that thought away with you, if nothing else. Now this zone of influence I've talked about, what is it? The process of identifying the zone of influence must consider all the impacts of natural features, not just within our site, but also around the site. So on this diagram that we have in our paper, everything within the blue line are the structures that we are constructing or hoping to construct. And at first look, you might think that's as far as we need to consider the ground. Everything within that blue line It's what we need to investigate and understand. But actually that's not the case, because to the top side of our site, there's a tunnel at some 30 metres depth. So we need to understand how that will interact with our structures. We've got a surface water feature as well. How's that going to interact with our site? So in fact, the red line is a zone of influence for what we're producing. It's a much, or potentially a much bigger area. Clearly, the ground model cannot be less than the zone of influence if we consider all these external influences. And we provide guidance in our paper on linking the ground model to the zone of influence in the form of various examples. Why is this linkage so important? Well, we need to understand what impact our structures will have on adjacent ground and on the ground properties. So, for example, if we're considering dewatering or ground freezing, or perhaps the placement of long soil nails, anchors or rock bolts that will extend beyond our site boundary, then we need to understand how that's going to impact on the surrounding ground. Equally, large bodies of water, areas of contamination, other hazardous ground, existing structures, deep pile foundations may impact on our site, insofar as the existing pile group zone of influence may overlap with our proposed structures. Similarly, any structures that surround our site that are subject to cyclic loadings may have an impact on our proposed structures. This table is, I think, key, and on the left-hand side, it gives the thought process that Håkan mentioned right at the start. The first thing when you receive a call from Eddie about a new project, initial project conception, and the right-hand side gives the key stages that are given in Eurocode 7. Okay, appointing the key professionals is not within the remit of Eurocode 7. The output for the ground model, as I said, is not within the remit of Eurocode 7. We're not being prescriptive about the exact type of ground model you produce. However, everything else in that right-hand column is given in Eurocode 7. So every ground model should follow this thought process from desk study down to continuous monitoring so that we can produce a verified ground model. Now, in terms of input bases to the ground model, then these will be acquired over a period of time, because the model is live, as I said, throughout the whole life cycle of the project, including all the construction process and subsequent monitoring. And obviously this period of time will depend on the complexity of both the ground and groundwater conditions under consideration, and also the construction process itself. Within each key input stage, the ground model should be formed of both the known and anticipated ground, geological, geomechanical, hydrogeological and geotechnical conditions at, under and around the site, i.e. within the zone of influence. And as noted previously, the zone of influence should be ascertained at an early stage of the life project, but it may of course change in scope as proposals for structures are refined or changed. But it's stressed that an accurate understanding of the zone of influence is key to ensuring that we capture all the appropriate inputs for our ground model. Again, this diagram is given in a different format in our paper, but it reflects, if you like, the key input bases on a timeline. So we start off right at the left-hand side there, desk study and site inspection, the first things that we think about or can do without actually physically breaking ground on the site. And of course, this will give us our anticipated ground model. We might decide then to do some preliminary investigations, some testing, some initial design work, and we come up with a preliminary model. For larger projects, of course, we might do additional testing, additional design work, and we have a more detailed model. And then coupling that with monitoring as construction proceeds, we end up with a completed or verified ground model. So again, these are the key stages in yellow, if you like. These are all given in the Eurocode, starting at desk study, site inspection, right the way through to monitoring. You can add additional input bases, of course, for very complex structures, but I suggest that these are the minimum that we should be looking at. In terms of the natural input bases then, these of course are the geological conditions, but they're not limited to description of site geomorphology, lithology of the units, potential presence and level of geometrical and physical properties and orientation of discontinuities and weathered zones in rock, and of course rock mass classification. Geomechanical inputs, perhaps preliminary assessments of in situ stresses, elastic properties and rock strength. And of course hydrogeological conditions, including surface water, groundwater and piezometric levels, including their potential variations with time and the presence of other fluids or gases affecting the site. And finally, geotechnical characteristics of the units that we've assessed are relevant for our site. For those sites where we think there might be a seismic issue, then that needs to be flagged up at an early stage, because it will have ramifications or implications for the site that go beyond all these other things that I've described. So based on our initial understanding of the ground and groundwater, the project and the type of construction we anticipate, then the complexity of the ground model may be constructed. And we've considered 3 levels in our paper. So we've got an overview model, that's a large scale model. We've got a systematic model, and then we've got a detailed model. And this has extract from one of the tables in our paper. Basically describes various aspects of the model that you might want to consider for each of these 3 scales. And of course it may be you require more than one model. So we're not suggesting that only one model is appropriate for very complex projects. It may be necessary to have an overview model and then to have several more specific schematic models to demonstrate specific parts of structures. And again, our guidance paper provides information on all these considerations. It's important to recognise there are other non-geological and groundwater related inputs that we need to consider. These include historical use of ground and existing structures or remaining substructures. So the historical use of ground is often considered as part of the desk study, from old historical charts or maps, aerial photography, etc., to help us prepare our investigation strategy. However, of course, a site visit also provides important clues about a former site use. We might see surface depressions, voids, discoloured soils, artificial soil and rock exposure can all point to human activity on the site, both at surface and also at depth. And again, these are some of the photos we give by way of example of the various things that you should be looking at in terms of previous site usage that might flag up issues. It's common, particularly in urban areas where we're building built up in cities or towns, that our construction projects are going to take place where previous structures have been. Often these structures can be dated to the last 200 years or so, but there are occasions where much older structures are present, and we need to take this into account. In all cases, careful consideration of existing plans is important to make sure that we identify all the buried elements of the original buildings and how they might interact with our foundations. Consideration should also be given to hidden infrastructure, cables, pipes, tunnels, potential archaeological finds. At a more detailed level, having identified that historic structures may be present on our site, then it may be possible to access foundation records. And even things like old timber piles can have a significant effect on our construction, and it's something we need to take into account in the ground model. In terms of inputs from the investigation databases that we accumulate for the zone of influence, then once we've got more information regarding the types of structures and their associated foundations that we're proposing, then we can start putting more specific information into our ground model. And these figures are taken from the paper and basically indicate that we can start looking at the zone of influence for individual structures and their foundations and add all that information into the ground model as we build up a more detailed ground model. Okay, so just to close my part of the presentation, some key takeaways regarding the ground model process. The ground model process can be as simple or as complicated as you want. It's entirely up to you. It's not prescriptive. It must consider the zone of influence. It's not meant to be an onerous task. So it's not meant to be a difficult procedure to derive a ground model. But if the process of constructing the ground model is done properly, and I'm sure you all will, and I stress that, you will identify potential risks on the site. That's the whole aim of the ground model, identifying risk. And you will help to eliminate unwanted surprises in the design process. I commend our paper to you because it gives some really good advice and helps to explain the overall process from concept to monitoring. Thank you.